Hey, John here. Let's talk about a queue. Now, a queue is a container adapter in the standard C++ template library. It is itself not a container. The way this thing works is it renames some of the methods on some underlying container object so that the standard terminology could be used based on the functionality of a queue. All right. Now, as it goes off and talks about it down here, it provides what we call a first in, first out data structure or service. And that simply means that where a queue is concerned, you can put a whole bunch of things in it and then remove them. In the way that order of removal goes is the same order that they went in. So in other words, if I put in, say, if I have a queue of integers or something, and I put in elements number 1, 10, and 100, and then I remove 3 of them, I'm going to get them out in the same order: 1, then 10, then 100. Okay? And as it says down here, it's simply a wrapper around the underlying container and provides just a few functions. All right? Now, those functions are push, pop. They'll tell you down here. You can look at the front and the back elements just like you can in a vector or a linked list. You can ask if it's empty. You can ask how much is in there. You can use push. You can use pop in the optimized in place, and the usual swap all the elements in one container with another. You can compare the contents of 2 of the containers with some other container, and as an optimized swap to replace all the elements, and some fancy allocator that you can change and tinker with if you want to optimize the way it uses memory. Okay? Now, the bottom line of this whole thing is you use push to put items in a queue, and you use pop to take items out of the queue. Notice it doesn't say push back and push front like it does for the deque and the linked list. All right? It just simply says push and pop. Over here it comments when you're pushing things in, it always pushes on the end. And when you're popping things, it always pops from the beginning, or the first element out. Okay? So that's really all this is. It's just something that renames a few methods on some underlying container. And if you look closely at the template definition up here, it says by default, it will use a deque as what we would call its backing star or its implementation, okay? Or the underlying container around which it will wrap these new accessing functions and stuff, all right? So this is just a way to rename some methods so that they make more sense if you're working with something that is a queue or a FIFO. That's really all it does. So let's look at a little bit of code to make sure that we all understand what this thing is. First in, first out. So what are we going to do? We're going to create a queue of integers. Okay? I'm going to call that queue. Then I'm going to push in 10 elements. They're going to be the integers 0 through 9. Okay? Then I'm going to run this through here. While there's something in the queue, while it's not empty, I'm going to just print them all out. I'll print out the front, and then I'll pop it. Okay? Now, the way a queue works, you don't pop it and then you get the value out of it. What you do is you have to get the value by asking what's in the front of the queue. And then once you consume it and you're done with it, you've used it for whatever you want, you say pop, and that will throw it away. It'll delete it, remove it, however you want to think about that. So I'm going to put in 10, and I'm going to remove 10 while printing them. Okay? Then what is this program going to do? It's going to put in 4 more. It's going to push in 0, 1, 2, 3. Then I'm going to just pop out 2 this time. Why? Because I can. Don't need to drain the whole thing. The point is, when you're using a queue, you don't always just use it like this. You're not going to just fill it up with a bunch of stuff and then be done with it, and then later on just drain it and throw it away. Quite often, you'll fill it up with some. You might consume a portion of that. You might actually then push more in. Right? So I'm going to push in 4, pop out 2. Then I'm going to push in 4 more in addition to the 2 that were left behind by this loop up there. And then I'm going to drain all of them and print them out again. Okay? So let's go ahead and compile this. And it does exactly what one would expect. I pushed in 0 through 9. I popped out 10 elements. What am I going to get? Or more accurately, I said, pop them until the thing is empty. And I got them out in the same order they went in. I then pushed in 4, and then I wrote a loop that just popped out and printed 2. And I left the other ones in there. I then started pushing 4 more in. So what happened? These 2 and 3 from the 4 that I put in before consuming these 2 are still there. So when I pushed in these 4 more before I printed out the whole contents of the queue, I end up with that, right? Quick review. Push in 4, take out 2. It took out 0 and 1 from the set 0, 1, 2, 3. It then put in 0, 1, 2, 3, okay? And then it consumed the 2 and the 3 from the first loop up here, okay? And then it consumed the 0, 1, 2, 3 from this loop down here. That's all this thing does. First in, first out. You can push as many as you want, and you can read as many as you want. You obviously can't read more than what's there, right? You can always read less, is my point. And then you get the rest later, okay? That's really all there is to a queue. Thanks for watching. See you next time.